axis, that will be mainly the phenomenon that will be presented through the numericals. Okay, and these are all important numericals. Now moving on to the direct topic. So what is the problem number 1 is given over here. Sketch the polar plot of the following system having GS equals to 1 divided by S plus 1. Now see what is the system we have. System we have basically the first order system. It is reflecting from the transfer function. And while we are obtaining that 1 divided by S plus 1, so what it is a single pole system having the pole position at S equals to minus 1, right? So it is having the pole position at S equals to minus 1. It is what you can say PZ map of the systematic domain representation. Okay, at S equals to minus 1, there is a single pole existing. Now, how to approach? What will be the approach of drawing the polar plot? That we have already done the concept, that part. First of all, this is basically GS. So you are putting here GS as 1 divided by S plus 1. Now, what is the first step? First step is you have to put S equals to 0 because we are basically going through the frequency response curve, right? So frequency response means we are putting basically the steady state response. So that concept is belonging over there, S equals to j omega. So you are putting here g j omega, that is equals to 1 divided by j omega plus 1, right? We are waiting for this welt here. So what is the magnitude and what is the phasor part, that you have to obtain. So what is the magnitude part? Magnitude part is equals to 1 divided by root under omega square plus 1, right? That's the magnitude part. Let me create a sketch and see. That is 1 divided by j omega plus 1. So what will be the magnitude? That will be root under omega square plus 1, right? And what is the phasor part? As it is the denominator polynomial, so we are getting here tan inverse of b by a. B means imaginary part divided by a. That is tan inverse of omega. So in the denominator polynomial, so in the numerator polynomial, we have only a real value, that is 1. So obviously it is contributing 0 degree, right? So total angle contributed by this phasor, that is equals to 0 minus of tan inverse of omega. That means minus tan inverse of omega. Okay. Now what will be the second step? Second step is we need to put the initial value of omega, because polar plot will be ranging, in polar plot the omega will be ranging from 0 to infinite for the whole positive values of omega, whole range of omega. So here mod of g j omega, what we are obtaining, that is 1 by root under 0 plus 1, that means 1, right? Omega putting 0. Now, what is the phasor part? Phasor part is minus tan inverse of omega. If you are putting omega as 0, you are getting 0 degree. So, what is your polar representation of this phasor now? At omega equals to 0, you are getting 1, 0 degree, right? And in case of the final value, you have to put now for omega equals to infinite, that is a final omega value. So you are putting here in the same expression of magnitude and phase, you will get here for omega equals to infinite, you are getting 1 divided by infinite. So that means it will become 0. So it is emerging to origin, right? And what is the angle? Angle is nothing but angle shifted over there. So mistaken. So angle, put here angle sign g omega h omega, that will become minus tan inverse of infinite. So what we are getting here, it is the angle reflecting minus 90 degree, right? So phase here at basically 90 degree phase difference. That means it is ending in direction of the polar plot, that will be clockwise. You can say like this way, or you can say that starting from 0 degree to minus 90 degree, right? So that's why polar plot is moving clockwise. So you may say like this way. So what is your observation? What are the steps need to be followed? First one is you have to go through the welt here, and you will put S equals to j omega. You will get the magnitude expression as well as phase expression. Now second step is you need to put omega equals to 0, that is the initial value. You need to find a phase value, magnitude as well as phase of that phasor at omega equals to 0. And at omega equals to infinite, you are getting the final value. That is your, what you can say, the magnitude is getting 0 and 90 degree. So you are putting in the polar form, that is 0 minus 90 degree at omega equals to infinite. So you are getting the final value as well as initial value. Or my suggestion is you can put it, make a table, and where omega you are varying from 0 to infinite, right? and the magnitude and phase along with you can put. Okay, that will be better for understanding. So for 0 omega rad per second, you can put the unit here. So you are getting here 1 0 degree as a magnitude and phase, and here you are getting basically the magnitude as 0 and phase value that is minus 90 degree. So in this way, you have the clear observation is that what is the magnitude that the starting vector is starting, what is the magnitude it is ending, and what is the phase along it. Okay, so you will get the clear view of the what you can say phasor. Okay, then you have to represent through the graphical approach. So we are moving forward. So what we say, the respective polar plot. So how to sketch? It is the initial value, and what we found, it is 1 0 degree. That is for the phasor. And you can represent here 0 degree. It will be better for the understanding. Okay. And it is your real axis, it is negative real axis, it is according to the convention j omega, it is minus j omega, right? Put arrowhead better. Put arrowhead. It is representing basically the axis, that's why put arrowhead, right? So while it is what was there, it is magnitude 10 degree, it is ended up to 0 with minus 90 degree. So you are sketching the freehand sketch. So that's why starting from this point, suppose it is point A, it is point O. So here the magnitude is 1. That means you can use a scale, or rather you can draw the freehand sketch. So this distance is showing 1 unity, and what is the angle? Angle is 0 degree with respect to positive x-axis. So it is shown. And similarly, it is vector length 0, that means it is emerging to the origin. And what is the angle? With the angle 90 degree, minus 90 degree. So it is just touching minus 90 degree line. That means it is actually getting the value of minus 90 degree of the phase value. Okay, so in this way you can sketch. So it is very simple manner. First step, but first step you have to put s equals to j omega in GS, HS. Closed loop transfer function. CL, CL, closed loop transfer function. Second is you have to obtain M5 form of that closed loop transfer function. It's nothing but a phasor. So that's why. Third is you will make a table of omega and magnitude versus phase. Fourth is you will sketch the polar plot. Very simple manner. Okay. So it is your observation is that phasor is starting from 10 degree angle and it is ended up to march to origin 0 with the angle minus 90. Very simple. Okay. So let me clear my sketch and we are moving to the next part. Now what is the problem number 2 given? Let's see. Sketch the polar plot of the system having GSHS equals to 1 divided by 1 plus SA into 1 plus SP. What does it mean? See, it is the second order system. As below, there are the 2 poles. So S square is the highest index of S in the denominator polynomial, as well as it is reflecting the relation in between input and output, that is of the second order derivative expression. And that's why after Laplace transformation, it is coming. Okay, so that's why it is second order system. And what is the pole 0 representation over there? There is no 0 in the system exists. Only there is a gain factor 1, unit gain factor. And it having the pole position. How do you get the pole position? Okay, so you need here A to be common as well as B to be common. So that's why it is S into 1 by A and it is S plus 1 by B, taking AB as common. So the gain factor is 1 by AB. Yeah, the gain factor is 1 by AB. Okay, so what are the pole positions? Pole position is at S equals to minus 1 by A, suppose, and at S equals to minus 1 by B. There are the 2 poles. If we are taking into consideration B is basically less than A. Okay, so that's why we are getting 1 by B. That is minus 1, minus 1 by B. This is a pole position P2 and this one is pole position P1. Now, it is not our concern. What is our concern is that it's the second order system and how to deal with. So it's very simple. So step 1 is you have to put S equals to j omega in OLTF. So what is the OLTF we obtain? Let me clear my sketch. What is the LTF we obtain? That is 1 divided by 1 plus SA into 1 plus SA. So that form is very much important. That will help you to get the magnitude as well as phasor cut very easily. Magnitude cut most of the time. Okay, that will be very easy. As because you know 1 plus k in j k omega or something else. So what is the magnitude you are getting? That will be basically very helpful, and try to practice it because it will help you in case of the other plotting also. Okay, so it is time constant form. You can it is not actually exactly time constant form. It is a form of basically what you have to free from this first factor constant. Okay, that is only one. That will be only one. So what we are getting over there, 1 plus s tau, that form, time constant form. Okay. So 1 plus s tau, that time constant form. Okay. So just practice it because it will help you in your future. So put s equals to 0, then GSHS you are getting what? 1 divided by 1 plus j omega tau a into 1 plus j omega b. Now what is step 2? Just magnitude you have to find as well as phase you have to find. So it is the M5 form. So you are getting M5 form. So what is the magnitude? 1 divided by root under this one, 1 divided by root under this one. That means finally you are getting 1 divided by root under 1 plus omega square square for this first pole factor. For the second pole factor, you are getting root under 1 plus omega square square. Now what is the phasor? For the first pole factor, that factorization will be there. It will be easier, not a compact form. Okay, for the denominator or numerator. It will be the pole factors and zero factors. That will be easier for getting the magnitude as well as phase. Okay. Now for the first part, you are getting first pole factor, you are getting minus tan inverse of omega as usual. And for the second part, you are getting minus tan inverse of omega b. Because both are in the denominator. So that's why you are getting the angle that is G omega H omega, that is a conjugate angle, that is as a whole representation is minus tan inverse omega A minus tan inverse omega B. So finally we got the M5 form, that is with the magnitude root under 1 plus omega square a square into root under 1 plus omega square b square. Okay, this is the magnitude, and your phasor is minus tan inverse of omega A minus tan inverse of omega b. Okay, so this is the composite magnitude polar form. Polar form. Now we will be going to plot this polar with respect to omega. So what we have to do? We have to make a table. So step 3 is we will make a table of omega with the whole range 0 to infinite. What will be M5 value for 0 and infinite? We need to find it. And let's make a table. That will be easier for you to get the polar plot. Okay. So let me clear my sketch and we are moving to the next part. So what we have here, let's see. For omega equals to 0, for the initial value, initial or starting value. So what we are getting, omega equals to 0. So what is the magnitude? 1 divided by root under 1, root under 1. So we are getting basically the magnitude 1. Okay. And for omega equals to 0, what is the phase? So phase value is minus tan inverse of 0, minus tan inverse of 0. So we are getting the angle 0. So what is basically we are getting for omega equals to 0, rad per second, rad per second, let us put the unit, rad per second, rad per second, what you are getting here, M5, sorry. Okay. So what we have here, table. So we are making here omega and this is M5. Okay. So what is the unit of omega? Rad per second. Put there. It is a group practice. Okay. So what we will get for omega equals to 0, we are getting the magnitude, that is unity in this case, and the phase is 0 degree. Just put there in the polar form. That will be easier. Okay. And for the final value, omega you are considering infinite. So what is the magnitude? You are getting calculating, that will be 0 surely. And what is the phase? Minus 90, minus 90. So each of the, what is your observation? When there was a single pole, so it has ended up to the angle minus 90. Okay. But the system having the two pole only, then without any zero, so it is ended up to minus 180 degrees. So what is the magnitude Pi, it is not degree, sorry, it is not degree, it is mistaken. So pi, basically magnitude is 0 with the phase angle minus 180 degree, it will be ended. Fine. Now, what will be your observation? For a single pole system, it is ending at minus 90 degree. And for the double pole system, it is ending minus 180 degree. Okay, I have to take the steps. So in this case, what you are getting that it is minus 90 degree and it is minus 180 degree. Okay. So that will be the observation. For a single pole system, you are getting it is ended to minus 90, and for double pole system, you are getting only double pole minus 180 degree without any zero. Okay, so from one quadrant, the thing has moved to the another one. So it is covering two quadrants. Okay, that is your observation. Now, so with this, we are moving. So let's see. So what we have here, the magnitude is unity with the angle 0 degree. It has ended to magnitude 0. So it should emerge to 0 origin. But what is the angle? Minus 180 degree. Okay. But in the previous case, what was there? Like that configuration. Just put the arrowhead. Otherwise, it will be meaningless because you are plotting the vector of phasor, right? So that was the observation for a single pole system. Okay. Now for the double pole system without any zero, we are getting here 1 plus s tau 1 into 1 plus s tau 2. So what we are getting here, there is another quadrant that's covered by the color. Just simply observe it. And it is crossing the j omega axis. Okay, negative j omega axis, that means minus 90 degree. It is crossing, intersecting the j omega axis. Negative j omega axis. Okay, so there is an observation is that intersection with the j omega axis. So you need to find what is a particular omega where it is intersecting and what will be the intercept. That means from origin to the point A. What is the length, vector length, while it is touching minus 90 degree. That means it is getting the angle minus 90. Okay, or there will be no real part at that point, only the imaginary part. Okay, because phasor is moving from the only real value, then it is covering as a whole the fourth quadrant, that is having the complex value. It is coming approaching towards the minus 90 degree. It is reaching minus 90 degree with the only what you can say imaginary value. It's a complete imaginary phasor then. Then it is moving again with the complex value, having real part as well as imaginary part. So it is pure complex, it is pure real, and intermediate is complex, intermediate is complex. Then it is reaching the origin. So, okay. So what will be the next part? Next part is we need to find the cross section with the j omega axis. So how to get G omega? We have to just divide it into two parts. One is a real part, another one is a imaginary part. Okay. So what is the real part we have observed over there? Just segregate these two parts. Okay. So the real part we are getting this one. So separating the real and imaginary part, the real part should be put to 0. Okay. So we will equate that part to be 0. Only it will be the imaginary part. Okay. Then we will calculate what is the respective omega. Okay. Let's observe. So what is the respective omega we are getting? The respective omega we are getting, that is 1 by root under AB. Okay. From soluting this, only the taking real part equals to 0. From A plus JB form. Okay. So real part is 0 while it is crossing the j omega axis. That is a constant. While it is crossing the j omega axis, the real part will be equals to 0. Okay. So we are putting real part equals to 0, we are getting the corresponding frequency, that is omega equals to 1 by root under A. Now what is the imaginary part? We are getting that is the part. So you are putting the magnitude because at that frequency at omega equals to 1 by root under AB, only it having the imaginary part. So imaginary part having its magnitude. So you will get here, putting the value of omega, you are getting the magnitude part, that is basically vector magnitude at that particular frequency. That means that is the intercept with the imaginary axis. Okay, and obviously the value of omega comes from by creating the real part, that is equals to 0. So plot will intersect the imaginary axis at omega tends to infinity. Okay, so let's see what is a phasor polar plot. Putting the value of omega at imaginary part. So what we are getting, what is the magnitude we have observed? That is, what was the omega? 1 by root under A. You can put it in the magnitude as a whole magnitude part also. Okay. So what we have the magnitude? We have the magnitude that is root under 1 plus omega square A square, and that was 1 plus omega square B square. So if you are putting the value of root under AB, so what you will observe? You will observe that one, right? Very simple. 1 divided by root under 1 plus, and observing everything, A square by AB, then 1 plus B square by AB, right? A cancel, BB cancel. So you are getting here root under AB is coming in the numerator part, and in the denominator part you are getting 1A plus B here into A plus B, root under. So it will become A plus B. So it is observing over here. Simple. Don't put this step, don't take, just put the magnitude of the phasor, that is omega equals to 1 by root under AB. That will be easier for you. Okay. This is the other way. So the angle is minus 90 degree you are getting, because you know that whenever, so minus 90 degree where you are getting the magnitude. Okay. So at omega equals to what you found, root under AB, 1 by root under AB. What is the intercept you found? Intercept is root under AB by A plus B. Okay. So this one is the intercept and this one is the corresponding frequency. Okay. And then it is moving again towards another 90 degree angle and is touching minus 180 degree. What is the magnitude? That will be 0. That will be 0. Okay. So this is the final sketch. You can just draw the freehand sketch like this way or any other way. Okay, any other way. Just it is the freehand sketch. So any other way you can draw. Okay. So let's move to the next part. So what is the problem number 3? Problem number 3 is, again see, there is another pole here that is existing at the origin. So what we have here, 3 poles. Okay, leading to pole in the previous experiment, that we have 1 minus A and minus 1 by B, and then again there is a third pole. So P1 at S equals to 0, P1, P2, P3, there are the 3, third order. Okay, so order is 3. Now order is 3, type is basically 1. Okay, pole at origin, that is a single pole at origin existing, but there is a 3 pole system. Okay, then again the same steps will be followed. Put S equals to J omega. Then what is J omega? J omega you are finding 1 by J omega into 1 plus J omega A into 1 plus J omega B. So for each of the phasor, treat this as a 3 pole factor as 3 phasor. So for each phasor, try to get the magnitude particular phase. So for J omega, what you are getting the magnitude, that is omega. For phase, what you are getting, as it is pole existing at the origin, so that's why what is angle? Only having the imaginary part, that will be minus 90 degree. Okay. Then for the second pole factor, that is 1 plus J omega B, as usual, that will be root under 1 plus omega square A square. And for this case, what will be the angle? Minus tan inverse of omega A. And for the third case, third pole factor, so you are getting 1 root under 1 plus omega square B square. So you are getting here angle minus tan inverse of omega B. So this is the third pole factor. So you got here conjugate angle minus 90 degree minus tan inverse of omega minus tan inverse of omega B. And what is the magnitude? 1 by omega into root under 1 plus omega square square into root under 1 plus omega square square. So additional, from the previous example, additional part is there, that is omega, and additional phase part is there, that is minus 90. Okay, just try to observe and compare. Let me clear and move forward. So what you have to find, now you have to imagine. Okay, so you are starting with the omega equals to 0, and what is your phase and magnitude of the phasor. Okay, so what is the magnitude of the phasor? Let's find 1 by root under this 2 part as well as omega. So while you are putting omega equals to 0, automatically it will become infinite. Okay, and what is the phase? Phase is nothing but minus 90. All will be 0. So we are getting minus 90. So what is the magnitude and polar form? Phase with respect to omega equals to 0, we are getting this. And then for final value, omega tends to infinite. I have to do something else. At omega equals to infinite, then what you have to do? Here, just put omega equals to infinite, you are getting the magnitude 0. Then while at omega tends to infinite, then what will be the phase? It is contributing automatically constant 90 degree. It will be 90 degree termination value. It will be 90 degree. So 390s are coming. That means it is covering first and negative quadrant and the fourth quadrant, then third quadrant, then it is coming to the second quadrant. It is ended to the magnitude 0. So it is merging to the origin. So you can say here 0 magnitude with the angle minus 270, right? So you have to imagine. So what is the starting magnitude? Infinite of a phasor and with the angle minus 90. So phasor having the magnitude infinite. So phasor if having the magnitude infinite, so what is the distance from the origin? That is infinite. So you have to show. And as well as what is the angle? Starting angle is 90 degree, minus 90. So it should be parallel with the minus 90 degree, right? And what should be the phasor magnitude? That is infinite. You have to show. Okay, so you can draw like the parallel line, starting parallel line with the minus 90 degree or minus kilometers. That will be showing you the magnitude infinite as well as the angle minus. Now, omega equals to infinite while you are getting the magnitude 0. So it is simply submerging on the origin, in the origin. So it is just merging to origin with the angle minus 270. That means it is just touching minus 270. That means positive joint. So in the path of traverse of the phasor, it is crossing minus 180. That means negative real axis, right? So let's see. Let's have a look. What is the diagram presented in my next slide? Okay. So the diagram is that, see, you can simply draw the parallel line that is showing that suppose it is the so what is the length is showing? Length is showing that it is infinite. So your phasor having the magnitude infinite at omega equals to 0. And what is the angle? It is parallel to 90 degree. That means it is at the angle minus 90. Okay. Now phasor will move and it is crossing minus 180 and it is emerging to 0 because what is the final magnitude? 0. So it is emerging to origin and with the angle minus 270. So it is showing with the angle minus 270 means it is touching basically minus 270 at the origin. Okay. So it is the sketch. Now, if this is the sketch, then what will be your next step? Next step is you need to find the cross section with the negative real axis, or while it is attaining minus 180 degree angle. Okay, let's clear the sketch and just move to the slide. So what you are getting here? You are getting, now you need to find the cross section with the genitals. My negative real axis. So you are segregating real part and imaginary part, and obviously in the this cross section where it is attaining minus 180 degree and with the what you can say that your cross section with the real axis, that means your imaginary part that will become 0. So segregating the imaginary part that will become 0 and we will get the respective frequency, right? We will get the respective frequency. So what we'll get? We will get again the respective frequencies is 1 by root under AB. Okay. Now you have to put the in the magnitude. So what is the magnitude? Magnitude is nothing else root under 1 plus omega square square root under 1 plus omega square square. Just put the omega value is 1 by root under 80. So what you are getting? You are getting here that is 1 by omega, right? That means root under, sorry, 1 by root under 80 equal root under 1 plus omega square square, that will come a plus b, that we did already, root under a, and that will be a plus b root under b. So root under ab while coming in the numerator, you are getting ab value by a plus b. So that will come. Okay, let's see. So what we have here the magnitude at particular frequency that we have derived, that is a cut with the negative real axis, that is with the frequency AB, that will be equal to AB by A plus. That is observing over there. So it is showing the length, that is AB divided by A plus B at the frequency, omega angular frequency omega equals to 1 by root under 8. Okay, it's very simple. And you can put also what was the angle theory, that is minus 90 degree tan inverse of omega A minus tan inverse of omega B, that will become minus 180. Okay, so it will be easier. So from these two adjustments, we are getting here 90 degree with the angle tan inverse, just summation of these two. We are getting omega A plus omega B by 1 minus omega square AB, right? Now, if it is 90 degree becoming, so that part will be infinite, so denominator part will be equals to 0. So what will get omega? Omega equals to 1 by root under AB. That is same omega is coming. Then you are putting the magnitude of that particular frequency, you will get the magnitude, that is AB divided by A plus. Very simple. Okay, so like this way you can proceed. So for today it is enough. We have done the numericals having with the cross section of the geometry axis as well as cross section with the real axis, as well as the numericals having no cross section, but that is the basic thing. Okay, so what you can compare for the first numericals, you are getting that there's only a single pole and having a simple pole. Simple pole. Okay, simple pole means suppose 1 by s plus a. You are in the pole at a single pole, that is s equals to minus, right? With no zero. Then we did the numericals having the pole, having the double pole, but here the pole position differs. S plus A, S plus B, suppose. So there are the two single poles. So that polar plot moving from 90 degrees to another 90 degrees, traveling another, what you can say, the quadrant. Okay, then each of the pole contributing minus 90 additional, right? So that's why it is the polar plot is moving from first quadrant to the second one. Then when another additional pole is coming, so polar plot is moving another 90 degree angle. So the final resultant angle will become 270. So it will be your observation for the polar plotting, that how the plotting is different from system to system, and it is depending on the poles and the zeros of the system. The pole and the zeros of the system. The magnitude will depend on the pole, basically the pole positions. Okay, but while the final angle and the initial angle will not depends on the basically the what you can say, the attributes. Okay, so in this way you can compare the polar plotting among all the systems, and you will try to relate it, and then that will help you for understanding of the Nyquist plot that will be done, as well as what is the system stability that will be done. Okay, so thank you for today.